Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we had did a numerical which was based on entropy change, and now we are going to do another numerical with different data, and let us solve that also. So this is a question which is related to the entropy change. So let us observe the question that what they have asked us to find out. So we have to consider the reaction for the dissolution of ammonium nitrate, and in this case the reaction is been given where ammonium nitrate is been dissolved so as to form ammonium ions as well as the nitrate ions, and in this process the delta H, that is the enthalpy change, it has been found to be plus 28.1 kilojoule per mole, while that of the entropy change that has been for this reaction is been found to be plus 108.7 joule per Kelvin per mole. So on that basis, we have to calculate the change in entropy of the surrounding and predict whether the reaction is spontaneous or not at 25 degrees Celsius. So based on the enthalpy as well as based on the entropy, we have to calculate whether the reaction is being spontaneous or not. But moreover thing that I want to tell you that in this process, basically as you could see that the delta H is been positive, so this is nothing but an endothermic reaction. And in this case, the system which has a value of positive, that is 108.7 joules per Kelvin per mole, and in this case it has been positive, so it could be a spontaneous process, but it is not necessary that it would be spontaneous unless we compare it with the surrounding, and if we add both of it so as to make the total, that is the change in enthalpy, the total change in enthalpy, if we found out that to be more than 0, or if that is positive, then only it could be said as spontaneous, otherwise it won't be. So let us calculate the thing, that is in this case we have to calculate actually the enthalpy change of the surrounding as well as of the total enthalpy change, the total entropy change that we are going to calculate, and on that basis we are going to predict whether the reaction is spontaneous or not. So first of all, let us see the data that they have provided to us. So the data that they have provided to us is first of all, temperature is the main thing that will be very much useful in this overall process to find out the entropy of a particular system or of a particular surrounding. So it has been found to be that is 25 degrees Celsius. So I could convert it into Kelvin as it would be 298 Kelvin. So this is the temperature that we have, and moreover what we have is we have delta H, which has been for plus 2 that is 28.1 kilojoule per mole. But the thing is, we have to convert it in joules. Why? Because the entropy value is also being mentioned in joules. So therefore, for a better convenience, what I am going to do is I am converting this kilojoule into joules. So therefore, this would be plus 28.1 into 10 raised to 3 joule per mole. But this enthalpy that we have is for the reaction, and the reaction is being considered to be the system. So therefore, in this case, the enthalpy change is nothing but the value of the enthalpy change of the system that we have. And in this case, also they have mentioned is that the entropy change that is being found to be, that is the delta S of the system in this case, is being found to be that is 108.7 joule per Kelvin per mole. So this is the data that they have provided to us, but on that basis we have to calculate that what would be the surrounding, because the system value is been known to us, but the surrounding value is not known to us. So the first thing that we are going to do is we have to calculate the entropy change of the surrounding. So for that we have, so in this case what we have is we have a relation between the entropy change of the surrounding and the enthalpy of the system, and that is the entropy change of the surrounding is equals to minus delta H of the system divided by the temperature. So in this case the enthalpy change of the system is being given as 28.1 into 10 raised to 3, that is joules per mole, is what they have given to us, divided by the temperature, and the temperature in this case is being calculated to be, that is 25 degrees Celsius, but when we have converted into Kelvin, it was found to be 298. So let us see what would be the answer for this case. So it is been found to be minus 0.094 into 10 raised to 3, that is joules per mole. So for a better convenience, what I will I'll try to do is I'll multiply this with 10 raised to 3. So therefore this will give me a value of minus 94 joules per mole. So this is the value that we have got for the entropy of the surrounding. But this is not done yet. We have to calculate the entropy of the surrounding also. So for that we have calculated, but we have to calculate the entropy of the total entropy change that we have. So for that we have a formula, that is the total entropy change is equals to the entropy of the system, the change in entropy in a system, plus the change in entropy of the surrounding. So in this case, the entropy of the system is being calculated to be, or it has been found to be, that is 108.7, while that of the surrounding, that is the entropy of the surrounding, it was been found to be, that is minus 94. So in this case, what we are going to do is we are going to do, and we'll find that what will be the value of the delta S total, which is now found to be basically 14.7. So this is the value of 14.7 joules per mole that we have got to know, but the unit was divided with time, temperature also, so therefore this would be per Kelvin. So this is what we have for the total entropy change. And in this case, what we have observed is, we have observed that the total entropy change is being positive value, or we could say if it is more than 0, then the reaction is being spontaneous. So not only based on to detect whether the spontaneity of the system is been positive, we have to also check the total spontaneous process, or that is we have to check whether the change in entropy of the total is positive or not. And if that is positive, then only we could declare that the reaction is spontaneous. So I will write it as the reaction is spontaneous. So this is how we predict whether the reaction is spontaneous or not. So thank you friends for watching this video. I hope you have liked this video and you have got to know how to solve this kind of numericals. So share this video with your friends, and yes, don't forget to subscribe to Ekeeda channel. Thank you so much.